I'm going to work a few examples from section 2.5 on function transformations. In the previous videos we explained why the function transformations do what they do. Now let's apply that results. Okay, so I'm going to look at this fixed function f, and it's a formula for it's the absolute value of x, but we are restricting the interval for the domain to be from -2 to 3. Alright, so you're only seeing the graph show up above the x-axis between -2 and 3. Alright, so if those are the only numbers you're plugging in, the range you're going to get is from 0 to 3 on the y-axis. Now here's the questions we want to answer. We've got several different transformations below here. I'm going to do 2 through 5. We want to ask the questions, what does the graph look like, what's the domain, what's the range of the new functions, and we can write the formula in using the absolute value if we want. Okay, so let's go over to our scrap paper and I'm going to start working this out for the first example. You'll see that the domain is exactly the same because no matter what number you're plugging in for g, you have to directly plug that into f. Okay, so the domain is unchanged here. You're only changing the outside, you're not changing the inside. For the range that will be affected, we know the range for the function f is from 0 to 3. Alright, that says y's are between 0 and 3. Alright, but y is the same as f of x for the graph, so that's equivalent to saying that f of x is between 0 and 3. Now, the idea is we want to make this look like our function g, and all we got to do is multiply it by a quarter to make that happen. So we have to multiply left, right, and middle by 1/4. Okay, doing that, 0 times a quarter is 0. We get 1/4 f of x, and then that's less than or equal to 1/4 times 3 is 3/4. All right, so that tells you what your new domain for g is because we have the formula for the function g right in the middle. So it says that g of x, the output values for g, lie between 0 and 3/4. Okay, that's our new range for our function g. Okay, now that aligns with what we had said before on the function transformation explanations. If we multiply by a number in the front or on the outside, and that number is less than 1, it's going to vertically compress the graph by a certain factor, and then that factor is that number. So it's going to compress the graph by a factor of 1/4. Okay, let's take a look at that. So here we've got the original graph in blue. It's the graph of f of x. Okay, again, the range is from 0 to 3. For the transform functions, you pull these points, pull this graph down. Now the point where it's on the x-axis gets fixed. Okay, what you want to do if you're going to plot this by hand is look at these three important points, the left and right endpoints, and then where it hits the x-axis, or the middle point here for the absolute value, and then see what happens to those points. 0 times anything is 0, so in particular 0 times 1/4 will still be 0. That's why that point gets fixed. We're at height 2 here, multiply that by a quarter, you get down to height 1/2. We're at 3 here, multiply that by a quarter, you get down to 3/4. And then you repeat your graph. Okay, again, it vertically compresses it by a factor of 1/4. Okay, let's look at the next example. Alright, that was f of x, g is defined to be f of x minus 6, and then plus 11. Alright, so we know what this does. Okay, graphically, the minus 6, it shifts the graph to the right 6 units, adding 11 on shifts the graph up 11. So we know what the graph looks like. Let's compute the domain and range algebraically. Okay, for this one, the domain is affected here. We're changing the input. We're changing what's inside. So we have to use what we know about the function f. We know we're only allowed to plug in numbers between -2 and 3. So whatever we're inputting into the function f has to lie between -2 and 3. Alright, well now what's our input? Alright, going back to our definition, it's x minus 6. So that's what you're going to put in the middle of the inequality is x minus 6. Now what you want to do is solve that. Solve it for x. You can do that by just adding 6 to the middle, left, and right, and that gives you this inequality that x has to lie between 9 and 4. Alright, and writing this inequality out is the key to understanding why it shifts right. You're adding 6 to solve for x. That's why the graph gets shifted to the right 6 units. Okay, now the other part of this is going to be to do the range. Okay, we know for the function f that its range is from 0 to 3. So we know the y values are again between 0 and 3. Okay, we do the same kind of analysis every time. Y is the same as f of x for the function f. Okay, but notice that doesn't matter what you're inputting. All right, your y value is always going to be between 0 and 3. Whether you're inputting x or you're inputting x minus 6, you're going to get the same values coming out of the function f. All right, so now we want to make this formula look like our formula for g, so we add 11 to left, right, and middle, and then that says 11 is less than or equal to, in this case, g of x is in the middle now, 14. All right, so that tells you what your range is for the function g. Again, here we could have obtained that from the graph also. So let's take a look at the picture. All right, here's the original graph. All right, we move it left 6 units, or sorry, right 6 units, pardon me, and then up 11 units. We see that the domain is going to be from 4 to 9. The range is going to be the lowest value is 11, highest value is 14, just like we saw algebraically. Okay, now let's go to the third example, which is the fourth one on the handout, number 4. In this one, we're again seeing that the domain is unaffected. We're plugging the same numbers in. Any number we're plugging in for g, we have to plug directly into f, so we're plugging the same numbers in for g and f. The domain's the same. It's only outside changes for this transformation. All right, now to obtain the domain and range algebraically, you're going to write down that f of x must lie between 0 and 3. We want to get negative 2 times f of x in the middle, so we got to multiply everything by negative 2. Doing that, you got to remember, you have to flip the inequality. Okay, so we get 0 is bigger than or equal to negative 2 times f of x minus 6. Add 5 everywhere, because we want to make it look like the formula above. 0 plus 5 is 5, negative 6 plus 5 is negative 1. So now we've got that our new range, because we've got g of x here in the middle, is from negative 1 to 5. All right, the lowest value is negative 1, the biggest value is 5. All right, let's remember what this transformation does here. There's a couple of stages. Multiplying it by 2 stretches the graph vertically by a factor of 2. The negative reflects it over the x-axis. Adding 5 shifts the graph up 5 units. And take a look at that graph. We see it's a little bit longer. Okay, we've stretched it by a little bit. Okay, we stretch it first. So we're going to pull these points up a little bit. Then we're going to reflect that over the x-axis and then shift it up 5 units. Okay, doing that leads us to this picture. Again, let's make sure our ranges are matching up. The domain's still between negative 3 and 3. That's good. Our lowest y value is negative 1. Our highest y value is 5. That matches what we saw on the scratch paper. Okay, let's get to the last example now. Here it's g of x is defined to be f of 3 times x. And these are the hardest ones where you're changing the inside, but not just adding or subtracting, you're multiplying. All right, so it's an inside change, so it's only going to affect the domain. So we're going to write a similar statement that we had before. We know what the range, or sorry, we know what the domain of f is. It's the interval from negative 2 to 3. So any input for f has to lie between negative 2 and 3. All right, our input this time is 3x. So we've got to put 3x in the middle. And then what we're going to do is solve for x. To solve for x here, you've got to break the multiplication up. You're going to divide by 3, left, right, and middle. And that gives us your domain. It's negative 2/3 is the left endpoint. The right endpoint is 1. All right, and that's our domain for this transformation. All right, now let's look at that graph. All right, remember multiplying, just going back to the formula for just a second. Looking at back at the formula, we're multiplying by 3 on the inside, okay, and that has the effect of compressing the graph, not by a factor of 3, but by a factor of the reciprocal, by 1/3, okay, and that's because you're dividing by 3 or multiplying by 1/3 to solve for x in this inequality. Okay, so looking back at the graph, here the original is in blue. We've compressed it horizontally by a factor of 1/3. We've smushed it towards the y-axis in this case. Our new domain is negative 2/3 to 1. All right, those are the furthest left and right endpoints we see on the x-axis.